So now we will start with the first module, slope stability analysis. So from the GEO5, I'm selecting the slope stability module. First, I will give you the brief introduction to the user interface for your better understanding. So here we can check the file options where we can have the save the new files, open the existing files, and reopen, import and export the existing details. Mostly the complete design options will be on the right side. First we can see project, settings, interface, soil, rigid bodies, assign. This will be followed with the standard design processor. So first, in this tutorial I will be explaining an example which one or with one or two soil layers, how the analysis to be conducted. First of all, the project. We can have the project details like what is the project ID, description and customer, the details. So here I'm considering as a demo 1. In the settings we can select which standards we have to be considered for the design. Here we can select the safety factors, limit state, Eurocode, design approach 1, 2, 3 or Indian standards, whatever it may be based upon our requirement. So here for this demo I'm considering this factor of safety. So here we can see what we selected, factor of safety. Next, interface. So I will be checking the interface and just adding few interface details, approximately 0, some -4, 75. So here I'm adding textually, we can use the cursor to assign the points also. Both will be same, but here I'm using textually entering the points option, so that because I know the coordinates, exact coordinates where I want to be having my interface details. Yeah. So the first interface was added. So once the interface points are done, we can click on OK, and I'm adding the another interface. So I just created the second interface also, and here I'm making the third interface. So I'm adding the last interface. So all the interfaces are added. After that, we will be assigning the properties of the soil, and we will be considering the interface 2 as a rigid body. So first, soils, we have to add soils one by one. So here I am considering the first soil layer as gravelly silt, that is MG type of soil. So we have an option of taking the properties directly from this, which can be assigned directly. So here it is considered MG gravelly silt. So I'm taking that OK and assign. I'm just checking the properties. Unit weight 19, considering the shear strength as modulus more coulomb, and effective stresses and internal friction of 29, and cohesion as 8. So I will add these properties, and the second soil I will be considering as sand with trace of fines. So this, I'm taking the directly properties here, I'm adding it, and third layer is sandy silt. Right. Done. So here we can see the 3 soil layers with the properties. So now we can assign the soil properties. Before that, we considered interface 2 as a rigid body. So I'm taking the properties of the rigid body here. Taking the unit weight as 23 and taking the color coding for that gray. So here also for the soil we can give the different color coding just for our understanding. So now I am assigning the properties of the soils. First I will be considering as gravelly silt. Second interface as a rigid body. Third interface sand with trains of fines. Fourth interface sandy silt. So here I considered these type of soil layers in interface 1, 3 and 4. Just for our identification we can change the colors also. Yeah. So after assigning the soil layers, now we have to go forward for the analysis. Once you are assigned, after that we will have other options like anchors, nails, reinforcement, anti-slide, piles, surcharge, everything. So this will be considered later on after the completion of the first set of analysis. If something is failing or we thought it should be considered for the what you call further stability, if required we can consider any of these options: anchors, nails, reinforcement or anti-slide piles. So as of now I will be considering the surcharge load here. So this also we can add something textually. I'm considering the type as a strip. So here we'll have an option of strip, trapezoidal, concentrated or line load, whatever it may be. I'm considering as a strip. And type permanent load, it's not variable or accidental case. Location on terrain. I'm taking this from 24 up to 8.3 meters. And alpha is nothing but an angle with respect to vertical. Magnitude I'm taking 10 kilonewton per meter square. Sorry. Okay, 24. So here length is 2 meters, 26 on 24. We'll consider from 24. The angle is sorry. So here if you want to assign that, So because of the inclined terrain, it is difficult to add the surcharge load here, but it can be assigned. It's not a problem. So here, as of now, I'm just skip this option. I will just tell you the later. After that, water table. Here we can assign some water table, like groundwater table. So this we can be assigned somewhere from here to here. So it will be considered the water table here, and earthquake and the staged constructions. Once these staged constructions will be considered when we are having n number of stages to be analyzed. Let us say sometimes we'll have a complications like first stage there will be a existing soil here that we have to be excavated, and initial stage we have to check for the stability with existing soil, and after the excavation also that we can add it in the stages, stage 1, stage 2, that also will be explained later. And in the stage construction we have to consider the which type of design it is, permanent stage, accidental or seismic. So here I am considering as a permanent condition, and we have to run the analysis. Here we will have few options like circular or polygonal. Mostly we will consider the circular. If you want we can go with the polygonal also. Method of analysis, we have to choose whatever the requirement we have. Mostly Bishop, Spencer will be considering Bishop. And analysis type, standard is nothing but we have to select any of the 2 points where we have to do the analysis. If it is an optimization, it will be considered whatever the worst condition, that means the critical slip circle. So here I am considering the optimum condition only. And just for the analysis purpose, I have to be selected portion. So now we can run the analysis. So now we can see it will be considering all the critical combinations of the slip circle, and the analysis will be carried out based upon the grid. So here I will just show you after this analysis what is the grid patterns we can give. So here it is showing the factor of safety 1.27, which is less than 1.5, so which is not safe. So here we can see the grid search. So these are the grids which we can optimize, that means we can reduce the radius and we can check the analysis also, but here I'm just considering the optimized condition, and now the analysis is performed and it is not safe with 1.27 stability, sorry, factor of safety. So once the analysis is run, now we can go and check the other options like anchors, nails, reinforcement or anti-slide piles. So in the analysis, if we see this is the critical slip circle, that means there will be a chance of sliding at the toe. So we can check with some anti-slide piles at here. So this we can consider cross section circular and pile diameter as 0.3 or 0.4, 0.5, whatever we want to be. And distribution along the length of pile I'm considering as constant, that means no incremental with respect to the depth. Maximum bearing capacity 35 tons, sorry, 35 tons. Considering the passive force direction perpendicular to the pile. Spacing, here I'm considering the center to center spacing of 6 meters. Add and close. Sorry. Z we can edit it. Yeah. So we can insert the length here. Sorry, it is considered 0.05 only. As of now, I am considering 4 meters of length. So here we can see the anti-slide piles are assigned. Just for a visual representation, here in the 3D we can see how it looks like. This is the rigid body what we considered earlier. Now we are adding the anti-slide piles at the bottom, and now we will run the analysis and check the stability. So yeah, now it is safe with factor of safety 2.25, which is greater than 1.5. Similarly, we can use the other options like anchors, nails, reinforcement based upon the requirement. I added anti-slide piles because I identified that it is at of value somewhere here. The critical condition is somewhere we are getting here earlier. So if we don't have a rigid body, if we are having only the earth face, then we can go with the anchors and nails and the reinforcement details also. So similarly, we can add the other construction sequences also. Sorry, construction stages also. Just for an example, I will add one more construction stage and I will show you how it to be done. So here I am considering some earth cut. So I am considering some cut approximately like this. That means I'm just excavating this soil. That's what my consideration in the second stage. So after the cut, I can run the analysis again. So here we can see 1.96 is the factor of safety. So in stage 1 we can see the soil here. Stage 2, without that soil the analysis will be done. Similarly, if we want to do the other geometry also, we can make the embankment. That means we can add the soil, or we can excavate the soil also, and we can do the analysis similarly. So after the analysis, here we can see the pile verifications, nothing but this anti-slide pile verification. To do that, we have to launch the anti-slide pile, which is a similar module. No need of doing all this modeling again. It will be automatically consider the geometry and the properties of the soil, everything out there. Just we have to launch it and check the stability. That's it. Thank you.